We'll solve this differential equation g double prime equals g. G double prime is the second derivative of g, and g is a function of x. We first define h to be g prime. G prime denotes the first derivative of g. And now we have g double prime is equal to h prime, and h prime equals g because g equals g double prime. Now we have two simple equations, h equals g prime and h prime equals g. We now look at the first derivative of g squared minus h squared. It's 2g prime minus 2h h prime. And we know g prime equals h prime equals g. We are looking at 2gh minus 2hg, which is 0. That means g squared minus h squared is a constant. We now use c squared to denote this constant, and c can be any complex number. And now we have this equation, g squared minus h squared equals c squared. We set a new function s to be I times h. I is the square root of -1, and now we have g squared plus s squared equals c squared. The general solution is very simple. G of x can be a constant c times a sine function of ax plus b, and the s function can be plus minus c times a cosine function of ax plus b. And because g prime equals h, and we know h is s divided by I based on this definition of the function s is I times h, so h is s divided by I. Now we look at g prime. We take the first derivative of this sine function. We get a, this a here, times c times cosine ax plus b. And then s is this part, and then divided by I. Now look at this equation. What's the non-trivial solution? Well, the non-trivial solution is this. A must be plus minus I. What's the trivial solution? Well, the trivial solution is very simple. If g is simply 0, and then g double prime is also 0. Now let's look at this non-trivial solution. A must be plus minus I because over here this part underlined equals this part also underlined. Therefore, a must be plus minus 1 divided by I. Therefore, a is plus minus I. And this function g of x must be a constant c times sine plus minus ix plus b. We can expand it into a times sine ix plus b times cosine ix. Here, a and b are arbitrary constants. They can be complex numbers. And now, based on Euler's formula, e to the power of negative x is equal to e to the power of I times ix. And this is simply cosine ix plus I times sine ix. And also, e to the power of x is e to the power of negative I times ix. And that's simply cosine ix minus I times sine ix. And now we can see both cosine ix and sine ix can be expressed as a linear combination of e to the power of x and e to the power of negative x. And therefore, g of x can be expressed as a linear combination of e to the power of x and e to the power of negative x. E and f are arbitrary constants.